Bismillahirrahmanirrahim. Assalamu alaikum. This is my lecture 2. I am Dr. ADNAN. Uh, so today's topic is to know the areas. I start with the basic, that is how you calculate area using regular formulas. And if you have an irregular figures, then you can use other method that we will explain, and that is the topic of this course. So let's start. What is the area? You know, if you have a triangle, the area is half BH. If a square having side A square, rectangle, AB, trapezoid, half H, A plus B. And then there is rectangular polygons that have half NA square cot 180 degree upon N. For a circle, pi d square upon 4. Most of that you already know in your previous studies and previous. This is a very basic knowledge at this stage, and we all know that. Now, if there is a circular ring, pi r2 square minus ry r1 square, and if you want to have an area of any sector, then that's pi r square over 360. Circular segment, half r square, pi delta 180 minus sine delta. Well, delta is the angle between the segment of the arc. Then there is an ellipse, pi a plus b, and then the parabola 2/3 bh. Now, if you want to know the area by coordinate, what will you do? You know, when you do surveying, in order to do a surveying of a closed area from your basic knowledge of surveying one, what you do, you have a traverse, maybe of this shape or any other shape. Let's take this example traverse that has been surveyed, and you have the coordinates x and y. And if you have, if you want to know the area of traverse, of a closed traverse, I mean, then you can use this area by coordinates. And in a matter of while, you will see it's very easy and it's very much doable, and it's very nice time consuming. So this is very easier, as I said. And if you use the UTM coordinates, you will know what are the universal transverse Mercator. This will be explained to you in your second course, and like you see, UTM coordinates is like that. If I open a mobile phone and I want to share my location with my friend, I will send him or her my location. So what happens that whatever is the location, that the coordinates that is transferred, it generally known as UTM coordinates. Uh, that's how these UTM coordinates. Ordinary, you can also say that when you are using simple mathematics, these coordinates are usually UTM coordinates. There are other forms of UTM. Obviously, this will waste my time if I do it, because this is specifically be taught in other part of this survey course. Now, let's see. Now, what you do is a simply cross multiplication, and there is this one thing that you need to do. Wherever you start calculating, you finish at the same point. For instance, you have started with coordinates of A, and then you will finish at the coordinates of A. So that's why You have coordinates of x, a, b, c, d, e, and then x, a. Similarly, y, a, y, b, y, c, y, d, y, e. You see here that except a, no other coordinates are repeated. Let's take it like this way. Since it's a closed polygon, so where you start, you will finish at the same point. Won't leave it x, e, and y, because then this method we are using will be unable to calculate this area of the closed polygon. So whatever, I again repeat, the technique that I'm explaining you is only applicable to this closed figure, right? Now, what you do is we cross multiply the coordinates. For instance, uh, xa will be multiplied by yb, xb multiplied by yc, xc to yd, yd to xd to ye, xe to ya. Now, this we can call it as a plus coordinates. We will also use the other way around, in which y will come first and x will come second. So this can be yab xb, yb xc, yc xd, yd xc, and ye and xa. Now, so this, after the matrix computation have been accomplished, the plus and minus columns are summed and subtracted. The answer is divided by 2. This equals the area in the units. For example, if the units of your coordinates are inches, this will be square inches. If units of your coordinates are feet, then obviously this will be square feet. And as in this case, the coordinates were given in the form of meters, so that's why the area is in square meters. So let's see. For example, we have these closed towers that has coordinates of A 238 to 22, B to 25 to 28, C to 23 to 24, D to 277 202, E 202 to 38, A 78 22. Just forgive me for not repeating up to decimal places, but it's my point is just to explain the coordinates. Now, what you do? You will have two columns. We call this minus, or we call this plus, or this can be vice versa, because at the end of the summation, uh, the sign, uh, whatever is minus or minus sign, or minus sign is generally ignored. So this is why this is how you do what you do now. So you leave this first row because you cannot have this row. So what you do, you multiply 238 with 228, you will get 226, 264, 32. And you multiply y 22 into 225, you will get 2692. Then 225 to 224, you will get this value. 223 to 202, you will get this value. 277 to 238, you will get this value. 202 and 22, you will get a value of 2262. Likewise, you will multiply 228 by 223, you will have 24577, 224 by 277, 220, 202 by 202. This will again become this. I doubt the value is, you must check this. And then 238, 270, and this. So at the end of a day, you will have the values of xy and yx. And then you will find the difference. And if you say minus plus, fortunately this become positive. and then you divide it by 2 to become 5474, and this may be enough or this may not be enough. If you have to express your value in terms of hectares, 1 hectare is 10,000 square meters, so this value is 0.45%. You see, it's very easy. It's nothing. It's the simplest method that you ever find in surveying. Generally, my part is very simple. You will find in future as well. Now, what would happen if you have the traverse like this? What happens is that you may have a straight line, and then you have taken the offsets at different intervals, and now you are interested in knowing the area under this curve, or area under this polygon, you can say. How you will do it? First, I know this. First, you must know what is these values is simply the stations. So, what if you want to know what is the numerical value of these stations? Very simple. Just ignore this plus between it. So this is 0 feet. This is 50 feet, 100 feet, 150 feet, 200 feet, 250 feet, 300 feet, 350 feet, and 400 feet. So in this given figure, what you have done, you have measured the length between up to 400 feet, and at each 50 feet, you have taken this offset. That, for example, at 50 feet, 5.2, 100 feet, 8.7, 9.2, 150, 9.2, 300, 5.2, and 400. Now, there is a very simple formula of calculating this area. It says B. Now, B, I means the distance between these two offsets. If here there is no offset, I mean, then simply this is 0. And so B between these 2 points is 50 feet, as you can see. So B is common. You will only use the area when you have equal distances. If you don't have equal distances, then I will show you how to do it. So this formulation that I have shown is only applicable to the figure having a regular intervals. Now that's why we have the 50 is common. 200, 250, 50. Now H0 is the first coordinate, the first point. In our case, this is 0, and Hn is the last. So this have an offset of 2.8. These are the heights, you can say. So at A, this is 0, H0 is 0, and this Hn is then plus 2 times rest of the H. So 2 times 5.2, 8.7, 9.2, 4.9, 10.4, 5.2, 12.2. Because this 2.8 will not be considered because it has already been taken in this calculation. Again, you have to divide it by 2, and this becomes your area. Square feet, and if you want to convert any square feet to square meter, just divide it with 10. You must be wondering why, how do I know the units are in fits? Because nothing is written in this figure. So I just give you a very clue of understanding why I said that this is fit, this is not meter. You know, if you have been given stations, actually these 0 plus 0, 0 plus 50 are stations. If you have given stations where after plus there are two places, then it is fits. And if after plus there are three places, three numbers, then this is meter, right? So that's why since my distances are in fit, I also presume, and actually it is, that I'm using fit system. That's why my answer is fit. You could also remember, you can also find that this is the area of trapezoidal, different trapezoids, because we consider this is also trapezoid. It's all, actually it's not, but we consider all of the trapezoid, and we added the trapezoid and just simplified it. The area of trapezoid, as you know, H B1 plus B2 into H, like this. Now let's think, and let's take the example where you do not have these regular offsets. Then how would you solve this problem? For that, uh, again, this is 0, this is 60 feet, 140 feet, 240 feet, 270 feet, 375 feet, and 435 feet. Because again, I said, because after plus there are only two numbers, right? And we have an offset of 7.2 feet, 11.9, 14.4. But the problem in uh, this data is that it is, the offsets are not equal, like we did the previous example. So then, instead of using that formula, where obviously that offset is not common, you'll use different uh, area of different segments, and then at the end we will add them. So the first area, the offset between them 60. So I said 60, H0 7.2, H1 11.9, so 7.2 plus H19. Then the next offset is 140 minus 60. Again, you just ignore this plus sign. 140 minus 60, that's 80 feet. And then you left to add 11.9 and 14.4. Then there is a distance 240 minus 140. Then this becomes 100 feet. And the offsets 14.4 and 6.0. Then 270 minus 240, 30 feet. 6 and 6.1 will be added. You can see here. Then 375 minus 270. Some students do confuse our plus sign, just ignore that sign. So this is 3, and if we just remove this plus, I will say 375. 375 minus 270 becomes 105, that's why 105. And I'll add 6.1, 11.8, and last but not least, 435 minus 375, that makes 60, and 11.8 and 12.4 is added. And at the end of a day, all of them are added. And since 2 was common, divided by 2, this becomes 4492 square feet. And if I just divide it by 10, that's, I will get this 449.2 square meter. And if I divide it by 10,000, I will get 0.0449 hectares. So this is how you calculate the area of the boundaries, what we can say, area of sectors near the boundary in this manner. Let's move on to the other ways of calculating the areas. if this you have an composite figures like you see here, and again you can think that this is a closed traverse, and one question would then be, some of you may think, why not we can do it by the coordinate method? My answer is yes, you can do it, provided we have we know the coordinates of all of these points. Yes, we can do it. We know how to do it, but you know, this example, as I said in the start of lecture, there are many ways of calculating areas. So now, during this course of this lecture, I am giving you the different ways of calculating the areas. So let's say we have this thing. So this is very easy. What you do, you can divide these proper areas into proper figures. Like we can divide this AGC, we'll say this is a triangle. So we can say 1. Then we can say JG, this point, then E and C. This can be as a trapezoid. So we say we calculate the area of trapezoid. Then this is my triangle. Then this is also my triangle. This is trapezoid and this triangle. So if you can add these area of 6 polygons, you can say. Polygon, I mean, is something that's a closed figure, right? That polygon means have 3 lines. So you can say polygons, or maybe called many things like quadrangular or triangle, you know all this. So I can always know, and if you are some 1, 2, 3, 4, 5, 6, I will know the area. Now let's try to understand this figure. Now, sorry, this is the distance between those 2 points is 20. So AG is 20, and the height of this triangle GC is in bracket. So if I want to calculate the area of this triangle AGC, what I do, I need the base. Now this base is 20, and then I need the height. The height is 42. Obviously, the area of this figure will be half into 20 into 42. Now let's come how we'll calculate the area between G and this point, and this G something ECG. How we calculate this area? Now the distance B is 65 minus 20. So this becomes 45. And then the height, there are 2 heights, obviously. This is a trapezoid. So we will add these 2 heights. 42 plus 58 divided by 2 multiplied by 40. It will give me the area of this figure 2. I move on to figure 3. The base is simply 110 minus 65, and the height is 58. So 110 minus 65 multiplied by 58 divided by 2. 110 minus 90, 20 is the base, 60 is the height. So you will get the area of this figure 4. 50 into 50 is the base, 60 plus 20 divided by 2 is the height, so I will know the area of this. And similarly, the distance between this point and A and this point is 40, and then the height is 20. So 20 into 40 multiplied by divided by 2. So this is how I've calculated the area of this figure. Since you will have this slide, you will easily know what I've said, and even if I've not explained you, I would have given you this slide. I presume that this is the easiest thing. You can be confident. If you don't do silly mistakes, you all may end up with a very GPA. Over the years, I just keep telling my students that this is one subject where you you can expect high grades, and normally you do get high grades. So this is this is a uh, bonus subject where you can always get good grades, provided that you do it to adopt the approach that I just keep on telling you during the lectures. Now there is another way. There is this we have done. Okay, sorry. Now there is another way to know this, an easiest way to calculate the areas of using the coordinate method. What you do, for example, you can use the area, the technique that I am going to tell you here is what we call the technique of uh, calculating area by graphical method. Nowadays, there are many softwares that actually use this technique to calculate the area of the figure. The softwares are programmed in this manner. Okay. So what you do, if you have this figure, and if you are interested in obviously knowing the area between these point or this polygon or this figure, what you do, you just divide it into squares, right? So what you do, I'd say, for example, one square is 13 millimeter. So I have 13 millimeter squares, and now once divided into equal squares, then it's very easy. You see, you will use this square scale. So area of one square will be 13 multiplied by 13, because this is 13, this is 13. So this will be area on paper. This become 169. And since one unit on paper equal to 1000, that would mean 169 into 10 power 6 is the area of this one square. Let me tell you again. Listen to me and just try to understand what I'm saying. For instance, the length is 13 millimeter on the paper. So what is the length? Actually, we say 1 millimeter is 1000, represent 1000 millimeter on the ground. Or what we can say, 1000 millimeter, it represent 1. So obviously this will be 13,000, and this length is 13,000. So what you get? 13,000 to 13,000. That becomes 169 to 10 power 6. So what you do, you add all the squares, you will get one area. And then there are, there are cases of partials. With this, you cannot count this one. This is a part of a square, this part of a square. So if I, approximate, I can say this 4 square can be 1 square. So I will add this 4 square and this parcel, I will say this 1 square, and then other squares, and it's like this. I'll show you in this figure, like this. So you have full of squares, 63, and you say this, if I add all this, I can have 1 square. This can be my square. This is 1/3, this is 1/3, this is 1/3, and this. So that's why you may have a 63 squares, and then approximately you have 10 squares. Again, the judgment vary within the people. So what one can understand, that at least 63 squares are known to me. So the answer should be at least 63 times 13 multiplied by 13 into say 1000 square at least. And then some can count this, take the rest as 12 square, some can say no, it's 20, 15 square. So the rest is just and it's just an approximation. Obviously, people have different ways, and this doesn't matter a lot. So for us, let's say this is 63 1275 square. So area is simply 1 square is 13, and the map scale is 1000. And what I'm doing, why I'm trying to divide it 1000 here, is to convert millimeter to meter. That's why it's 1000. So don't get confused. Map scale can be 1:2000. So here maybe we'll have 2000, maybe 1500. But this 1000 is to convert millimeter to meter. Or if you don't like it, then that's perfect. You can have area in millimeter square as well. Then you convert accordingly. So what I have done here, I just take this, and obviously this 1000 is for in meters. What would have happened if I've taken this as 1 foot? Obviously, then you don't have, would have multiplied, if no, sorry, no, this can be millimeter or it can be in inches. I'm sorry, it cannot be like fits. So if it would have been this one grade, maybe say 13 inches, then this will not be 1000 here. It obviously, you are converting inches to fit, so you must have this value of 12, because 1 inch 12 inches becomes 1 foot. So that's why this may be 12 if it is you are in fits units. I hope you are not confused, and you will know. And square, because this, all of them are square. Or you could not have like this, but you could have like 13 multiplied by 13 multiplied by 1000 multiplied by 1000 divided by 1000. This also could have done. I just become fast because I thought it's very trivial to explain these things at this level. Just know this area again. Just keep on repeating that this may be 12 if this is in inches. Now we move on. Actually, I feel we are let's stop here in this lecture, because the uh, next thing is different what we were doing. You know, the topic we have covered till now is calculating the area of the bodies, area of the figures in plane. But in lecture 3, we will discuss the cross-sectional areas. So I hope the content that I have taught are very easy and you will do it. One thing before I close this video, uh, I have uploaded some tutorial sheets in your classroom. And actually those tutorial sheets covers all the course. So try to solve tutorial 1 up to this point. And I hope, and if you have some problem, you can always consult with me during the online lectures. So wish you a good luck, and Allah Hafiz.